This video explores the next measure of central tendency, the median. Unlike the mode, the median brings variability of data distribution front and center when combined with quartiles. Remember that this exercise is about turning statistical terms like median, quartiles, and percentiles into practical tools for business interpretation. We will focus less on complicated formulas and more on what these measures tell you about your data. Using a simple age example, we will briefly discuss how different methods might give similar answers and slightly different levels of precision. By the end, you should feel confident using medians, quartiles, and percentiles to read distributions, spot patterns, and support better decisions. When you look at a list of numbers, the first question is rarely, what is the exact average, but rather, where is the middle, and how spread out is this? The median and quartiles give you those answers in a way that is less affected by extreme values than the simple average. For a manager, this means you can talk about the typical customer, typical transaction, typical employee satisfaction level, or typical age of clients without focusing on the outliers or exceptions. Quartiles extend this idea by showing the range where the middle half of your data sits, which is critical for planning and risk assessment. The median is simply the value that cuts your sorted data into two equal parts. In business language, half of your observations are lower than this value and half are higher. This is especially useful when a few very high or very low values would distort an average, such as a few extremely large orders in sales data. In the age example, the median age of 26 tells us that half the people in the sample are younger than 26 and half are older, which gives an immediate sense of central age. Using the median as a decision anchor lets you talk about typical performance or typical customer characteristics without overreacting to outliers. This measure is often used in surveys to find the middle value for each response. The interpretation of the average is particularly interesting when using the median. Since outliers do not impact the median heavily, valuable information can often get lost in the pursuit of the middle measure. If you were rating employee satisfaction, for instance, a median value of 4 on a 5-point scale might be very encouraging. However, it becomes easy to lose sight of the fact that at least half of the responses are 4 or lower, and those might be the ones that require more attention. This can often distort the goal of surveys in the real world. Academic ease of use and interpretation work when data and outputs are controlled. But as a decision maker, always question where the average refers to a median instead of an arithmetic mean. Using typical instead of average will change the way you approach what this value really means. Quartiles break the same distribution into 4 equal-sized groups, which adds nuance and variation to the story the median started. The first quartile, or Q1, marks the point at or below which roughly 25% of the observations fall. The third quartile, Q3, marks the point at or below which roughly 75% of the observations fall. The interquartile range, or IQR, is simply Q3 minus Q1, and represents the spread of the middle 50% of your data. In our age example, Q1 is 22, and Q3 is 31, so the IQR is 9 years. A business leader could summarize this as, the middle half of our clients fall between 22 and 31 years old, which is immediately useful for targeting services or communication. In surveys, including the IQR for each question can help to see the spread of the middle 50% of your observations, and minimize the risk of overgeneralization of results. Extreme values are often where structural differences, performance problems, or breakthrough results become visible, especially when segment groups are not truly comparable. Percentiles push the same idea of cutting up data into equal parts further by slicing the distribution into 100 parts. Instead of asking, what is the absolute score, we ask, what share of the population is below this value? This is different from a percentage score on a test or a metric. An individual might score 65% on an exam but still be at the 89th percentile, meaning they did better than 89% of all test takers. In large business datasets, percentiles help you see where a customer, transaction, or employee sits compared with the full group. This relative ranking is often more useful for decisions than the raw score itself, especially when the scale of the metric is unfamiliar. Consider a sample of 30 clients whose ages were noted in a pilot test for a new product launch. When we organize and analyze these ages, we find that the median is 26, so half the clients are younger and half are older. The quartiles tell a richer story. Q1 is 22 and Q3 is 31, so the middle 50% fall between 22 and 31 years old. Looking at percentiles, the 65th percentile corresponds to age 29. So a 29-year-old client is older than about 2/3 of the sample folks. The same list of numbers now reads like a clear narrative about age distribution, instead of just a raw table of values. When continuity of data is less critical than specific benchmarks, medians, quartiles, and percentiles provide quick structural checkpoints. They divide the ordered data into equal portions, creating a practical baseline for comparing central tendency and spread, before moving into measures like the mean, skewness, and standard deviation. The strength of these tools lies in their simplicity and speed of interpretation, even if they do not capture every detail of the distribution's shape. Medians, quartiles, and percentiles are not just technical terms, they are storytelling tools for your data. Use the median when you need a stable, central figure that represents typical performance or customer behavior. Turn to quartiles and the interquartile range when you want to understand how concentrated or dispersed your values are, and where most of your cases fall. Apply percentiles whenever you need to explain how one person, transaction, or location compares against the whole distribution. As you work with real business datasets, choose the method of calculation that aligns with the size of your data and the level of precision you truly need. And let these measures guide clearer, more confident decisions.